but we needed to prove it to them. It was really important that they see that these fractions are getting smaller because we're taking a small piece or a fractional piece out of a fraction. Our value is getting smaller. We have worked very hard to teach kids that just because you multiply things don't get bigger. They'll be discussing that. When do they get bigger? When do they get smaller? So for multiplication, yes, it is numerator times numerator and denominator times denominator. And they will learn how to do that. We will get them to this point. But they will be asked to prove it, so they're going to have to be able to show us a picture as to why it works.
You answered my question.
I kind of thought, and I do know her. That was fair that I stopped her. Okay, I'm going to step away from multiplication because of course we want to go to the all-time favorite of division. Our tape diagram has shown back up again. This is how versatile a representation it is. So if I want to know, or if I have 1/4, and I want to divide that 1/4, let's call it a piece of cake, or pizza is the typical one. I have 1/4 left, and I now want to divide it among 3 people. What's my picture going to look like? Well, first of all, I need to find 1/4. So this is all I have in my problem. I now want to divide that among 3 people. Okay, I can do that. What is the value of this piece?
1/12.
Why?
I'm a mom of a 6th grader.
Yeah, I would like to see that written on the test because I'm the mom of a 6th grader. Where does that 12 come from? If we divide this 4 into 3 parts, we have to divide each of them into 3 parts. We now know, we can now count them up. There are 12 parts. And they got 1 of them. I did not say that this was 1. Now this is 2. I'm sorry, I'm on the wrong problem. We've got 1/3. This is still equal to 1. I want 1/3 of it. This is the part I'm working with. But now I want to divide this among 2 people. That's the way my brain takes these. I take it to dividing it among people. It's the context that I'm used to. So I want to divide this among 2 people. Okay, I know they're each going to get this much. What's the value of it? I have to divide each of the thirds into 2 parts. So how much does one person get?
1/3.
They get 1 out of the 1, 2, 3, 4, 5, 6. Sybil has half a pizza left over. She wants to share the leftover pizza with 3 of her friends. What fraction of the original pizza will Sybil and her 3 friends get? And I'm not, with the students, I would make them read this real carefully. I'm going to be nice with you. It is Sybil and her 3 friends. It's going to be, that's right, we've got half a pizza. This is what we have. But we're dividing it among 4 of us. How much would we each get? We get this one. We need to divide the other one into 4ths, the other half into 4ths, so I know their value. And I get 1/2 divided by 4 equals 1/8. In 5th grade, they will be asked, this is called a unit fraction, where there's a 1 as a numerator. They will be asked to divide unit fractions by a whole number. modeling. They will not take it to an algorithm. We will not go any further than this. They need to know how to be able to draw it, understand it. Now, it's shifting. Now I have a whole number being divided by 1/2. I want you to think just quickly, what is 4 divided by 1/2? Think about it in your head. Let's take a look. We have our cake diagram. I drew in the 4 for you. This is asking us how many 1/2s are there in 4? Well, here's one. Here's another one. Here's another half. Here's another half. Here's another half. Here's another half. I cut each one of my 1s into halves 4 times. How many halves are there in 4? 8. That surprises most people. Most people, when you ask that question, get the answer 2 because they really turned it into 1/2 of 4, which is a multiplication problem. Division is how many groups of. But as soon as you start drawing it, it makes sense. My guess is some of you will have kids that will draw this whole thing and still tell you the answer is 2 because they're not using their drawing. They're going back to what they thought. If they do that, don't tell them they're wrong. Ask them to prove it to you. You say it's 2. Well, there's 2. Oh, but there's 2 more and 2 more and 2 more. Take them back to the drawing for the proof. So 5 divided by 1/3. I'm going to divide each of my 1s into 3s. I should say 3 parts, excuse me. How many 1/3s are in there? I can count them. There's 1, 2, 3, 4, 5, 6. Well, actually, I can multiply. I've got 5 groups of 3 parts, and it's going to equal 15. I have 15 groups of 1/3. But your students are only being asked to take it to the model. When do we use this in real life? Mrs. Silverstein bought 3 mini cakes for a birthday party. She cuts each cake into quarters and plans to serve each guest 1/4 of a cake. How many guests can she serve with all her cakes? We don't ask kids to draw pictures of the story, we ask them to represent it. So I'm not going to draw 3 lovely little round pink cakes. I'm going to draw the cake diagram. So I have my 3, and cuts them into quarters. How many does she have?
12.
You can't see, thank you. Well, she has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 divided by 1/4 equals 12. This is, to me, the hardest thing your child is going to do with arithmetic in elementary school. When we take them to word problems, they tend to do better. It puts it into a real context that they can understand as opposed to just numbers. So if your student gets something like this, turn it into a word problem, something they can understand. You've got 1 sample. As soon as you have 1 sample, it's usually easy to come up with other problems. They are going to be asked to write the equation, but not solve it numerically. But they do need to know that this was 3 divided by 1/4. But they would be solving it by drawing a picture. So in 45 minutes, you just got a 7-week course. A lot of it was probably, the way we did it was probably new to you. Think back to what you know how to do, and you probably can make connections to what you just did. We're just making sure the kids have a conceptual understanding of what's going on. Because I know, I'm older than everybody in here, to divide a fraction and to multiply a fraction. I know that one of them you invert and multiply, but I never knew which one. So for me to solve it, I would take an answer I knew, test it, and then go and apply it. I didn't know what I was doing. It was an absolute memorized way. I found a cheat sheet way around it, but I didn't know what I was doing. I could get the right answer, that's all I got. Yes?
I just want to share something. I don't know if there are any grade 6 parents in this room. I wish this session was done at the beginning of the year, because what I've said to my son, because he had a test in grade 6 in division of fractions, I said to him what I knew from school, and I was a great mathematician at the time. Whenever you have a division of fractions, you always invert the second one and multiply.
Yeah.
If I had this knowledge 3 weeks ago, probably he would have got, because we're working together for his test, he had exactly the same questions, 3/4 of 2/3 of
And-
a kilometer. How many meters is that?
And in 6th grade, they are taking it to the equation and solving it.
I'm very sad that was not done, because it would be so easier for us to support them.
I'll tell you, this is the second one we've done of this. I did one last week and one this week. The overwhelming response has proven to us that there's a need, and it is my goal to continue these. I
don't know if you can-
I can talk to the lead teacher in math up in middle school and tell him he should start doing it because it's my husband.
It would be very precious to have
Okay.
sessions like that.
I will
because-
pass that along. Middle school, getting here.
Yes, we do need that, because
Oh.
the knowledge is
And
very-
her husband's the principal, so. Okay, thank you very much. I'm open to more questions. There is a feedback form. What worked, what didn't work. You're welcome to take these manipulatives. You are more than welcome to take them. If you're not going to use them, I would also be glad to keep them. And when I say the manipulatives, I only mean these. These. I need to keep the Unifix cubes. Yes, please take them. If you want them and you're going to use them, please take them. If they're just going to go into the bottom of a backpack, I would rather keep them. Yes, there you go. Wasn't that Uh-huh. Yes, I worked with her last year.